the report to help you fill that out.
Thank you for that information. We need to go on at this point. Our next speaker is Fumi Yoshida. Fumi is an active occultation observer in Japan and has participated with a number of Japanese observers in combined observations of occultations. And she has been working on establishing an East Asian occultation group, somewhat analogous to other groups that have branched off from IOTA, such as IOTA ES and IOTA in India and IOTA in Middle East and so on. So she's agreed to give a talk about some of those efforts she's made in getting that East Asian group going. And I'm eager to hear what you have to say, Fumi.
Yes, thank you. I'll share my screen. This one. Can you share? Can you see my screen?
Yes, it's just fine.
Okay. Thank you. Thank you. Introduction. So recently, our group decided to have an organized group of occultation observers called IOTA EA. So it involves the observer not only Japan but also East Asia. Then, so today I'd like to talk about the background of formation of IOTA EA and what we are trying to do with IOTA EA. So this is so this organization will be officially launched with inaugural meeting on August 27th this year. So this is the IOTA EA's structure. So IOTA EA is a joint organization of professional astronomers and amateur astronomer. So it consists of core member and the regional director and large number of members who are officially registered after the inaugural meeting. So there is 8 core members, including well-known Mr. Hayamizu and Dr. Soma and Mr. Miyashita and the others. So we are preparing to start IOTA EA with these 8 members. And we have appointed 1 representative in each region other than Japan. So Dr. Yuan and Dr. Lin and Mr. Ye, they are leader of the observing group in each region who are many experience in observing occultation. So these 11 people will be the center of IOTA EA. Then I'll talk about the background of organization of IOTA EA. So at first, the researcher on planetary exploration mission sent a strong lab call to amateur astronomers. So we need, because the science team of Destiny Plus mission have to decide, have to determine the exact size of phaeton, which is the flyby target of Destiny Plus mission. So Destiny Plus science team called for the phaetons observing campaign, then radar observation, photometric observation, and spectroscopic observation were made during the phaeton's close approach to Earth. in December 2017. Then we studied many kind of Phaeton's physical property. However, one thing we could not obtain is absolute magnitude. So due to the Phaeton's peculiar orbit, there is no chance to observe Phaeton at the solar phase angle of 0. So this makes difficult to estimate the exact absolute magnitude, which is a basic parameter for estimate the asteroid diameter. As a result, the estimated diameter of Phaeton had a large error. So we give up absolute magnitude. Instead, we decided to estimate the size and shape of Phaeton with the help of occultation observation. Then we organized a joint professional amateur team like this. Then first observation of this team was in Hokkaido, Japan, August 21st, 2019. But weather was very bad, so we couldn't get any data. I remember that iWater had contributed greatly to predict this Phaeton's occultation event. So we are very, very grateful to iWater for their help. So although no data could be collected due to the bad weather, the unity of professional and amateur team at this time became a strong motivation for formation of iWater EA. So we are looking for the next observation opportunity. Then during the 2 years, many observers had prepared equipment, GPS module or CMOS camera and so on. Then challenged the observation on October 3rd, 2021. Then this observation was very, very successful. So I think this is the most successful occultation observation of Phaeton today. Then we learned how to conduct the observing campaign, and then we carried out these observations, so many. Now Japanese observer can handle observation of occultation event with occultation duration as short as 0.1 seconds with the brightness of the occulted star of less than 11 to 12 magnitude. That's great. So this is IOTA structure. So Japan has a joint. So since 1995, joint is Japan has a joint. So joint is a group of the individual observers who have a lot of experience and knowledge of occultation observation. Then the role of iWater EA is to share the knowledge and experience enjoying and expand the number of occultation observers. So iWater EA also cooperates with the neighbor country and aim to become an organization that collaborates on space mission and scientific observation proposed by researchers. So iWater EA provides occultation prediction for observer in East Asia region and collect observation results and report them to iWater and then IAU. Then we archive observation datasets and launch an observation campaign and conduct a workshop and distribute your observation manuals and share the observing method and analysis software. Then we will publish the IOTA EA activity through the web page. So since no common language in East Asia, so it is very difficult to share the information. So therefore, we have appointed regional director in major region. Then regional director as an actor liaison between IOTA EA and the observer in each region, where the director decides for information sharing. Then we currently have a regional director in mainland China, Hong Kong, and Taiwan. And we hope to extend this observation network to our friends in Southeast Asia and Central Asia region in near future. So this is the part of the IOTA EA website. Many parts are under construction, but the best feature is in the ability of automatic translation into multiple language. So you can select language from the tab. This is the automatic translation. So that's why the quality is not so good, but better than nothing. The web will be ready just before the inaugural meeting. So please visit our website after the meeting. So this is the prediction page. The IOTA EA staff select and list the observable occultation event in East Asia. Then observation result will be also appear on the website. And this is our data archive site. So we will collect AVI file and camera setting information from each observer from here. So observer upload their observation data from this site. So data from each event stored separately. And currently we have 12 terabytes of disk space. When the space runs out, we will purchase hard disk with the IOTA EA membership fee, which is about $10 per year. So we have issued a broad call for symbol mark of IOTA EA. Then we have already received several applications. So after the review process, the symbol mark will be officially unveiled at the inaugural meeting. And we are preparing the observing plan for fiscal year of 2023. And the main event is occultation observation of Phaeton and 2005 UD. It is considered to be a spirited object from Phaeton and second flyby candidate of Disney Plus. So in addition, we also have we plan to make a observation in search of ring and satellite for distant objects. So once IOTA EA is established, we would like to contribute occultation observation in the East Asia region in close cooperation with IOTA. So thank you very much for your kind attention. So that's all.
Thank you, Fumi, for a fine presentation. And it's really interesting to see how things are coming together there I know that a number of us have been delighted to work with observers in Japan, in particular, in the last year about some of the Destiny mission objects and so on, as such a, and CC-21 is a good example. So thank you for showing us what's going on there. Are there any questions for Fumi Yoshida at this time?
I have a question.
Yes.
Yes, hi. Yeah, this is Richard Kelly. I very much enjoyed your talk. I have a question. In one of your early slides, you show the hardware, particularly the cameras that you use for recording occultations, and you show the ZWO 290 mm, the red camera there.
Yeah.
Was wondering in that scenario, what do you use to attach the GPS timestamps to the data?
So we this module. So can you see my pointer?
Yes.
Oh, yeah. So this module receives the GPS signal and collects then light illuminates the GPS some LED light per second.
I see.
And yeah. Then we this signal go to the image on the image. Then we measure the light curve of the this signal, and after that we use the light movie to analyze that this light curve.
Okay, that's very interesting. What time resolution or sampling rate do you achieve?
Oh, that's very, very short. Maybe about this observation, we take the 30 frame per second.
30 frames per second, okay.
Yeah, I think more than that with this camera. We are able to do more than that with this ZWO ASI 290 mm. This camera is a very sensitive, high sensitive than this QH5.
Right.
Yeah.
Okay, that's very interesting. Yeah, I look forward to learning more about that once I study your slides further. Thank you.
Yeah. We will distribute the observation manual with this instrument soon in English. We have a Japanese version, but then yeah, we will translate to English.
Okay, thank you very much.
So the timestamp is like ART's Arduino flasher that some of us in IOTA have used. It flashes the LED light at the onset of the per second signal from the GPS device. And that's how we've been getting time stamps with the ZWO cameras. Okay. If there are no other questions, I'd like to move on to.
I just have one question.
Okay, go
I
ahead.
think in the 2021 Faith on Occultation, you had some observers in South Korea. So I hope you can find a coordinator there to also join your effort. There are also contacts, I think, possible in Thailand and the Philippines.
Oh yeah. I hope so. So we try to contact the Korean group, but he moved to institute from the science field to just a company. So this time we couldn't, but I'll keep searching the such person. Thank you.
Dave Harold, your hand is still up. Do you have another comment?
Yes, just a quick comment about, I think from Richard's question about time resolution. I just thought I'd briefly mention that as between having very high time resolution and having certainty of the observation is far, far more important than having incredibly high time resolution. Accuracies of 0.01 of a second are generally more than adequate for our work. Seems to be a lot of people want to maximize the accuracy of their time and report times to 0.001 of a second. And usually that extra precision when it comes to analyzing the results doesn't add anything at all. And if as a result your light curve is very noisy, then that's a backward step.
Okay.